All right, so we're given the head of a singly linked list. They want us to reverse the list and then return the reverse list. So they give us this list in C++, which is just a bunch of these struct list nodes. It's just a bunch of pointers to those guys. So we have these list nodes they have a integer value, and then they have a pointer to a next list node. So if you put a bunch of those together, you get a singly linked list. If they had a next and a previous pointer, you get like a doubly linked list, but this one's just singly linked. But anyways, yeah, let's look at the example. So like if we have this list, it's reversed. So the 1 is going to be pointing to nothing. It'll have a null pointer, and then the 2 will be pointing to the 1, and then the 3 will be pointing to the 2, and then the 4 will be pointing to the 3, and the 5 will be pointing to the 4. And then that's like, yeah, you can see it here. And then they want a pointer to like it would be the last list node from the input list, right? That's going to be the first one, or the head of the new list. So anyways, yeah, there's an algorithm where you can do this in linear time, because you got to like look at every single node at least once, right, to like reverse it. So it's going to be, that's the best we can do. And then we can also do constant space. So time complexity big O of n, and that's where n is the number of nodes, and then space complexity is big O of 1. No extra data structures, or we're not doing like a recursive solution or anything like that. So yeah, let's get into the problem. So let's say we have a couple of list nodes here, and they're all connected, and this is like the linked list they give us on the problem. They give us like a pointer to this node. So we basically want to be able to keep track of 3 nodes at any given point of time in our algorithm. We want to be able to keep track of the head node, or like whatever node we're on currently. We'll just call it head, right? Because that's the node that they pass in as a parameter. That's a variable name, that they give us. So this is going to be like the middle node, really, head, or we'll just say, or im up here. I don't know, maybe you could name it im, but it's for mid, but it's the head node. That's the variable we're going to use. And we also need a next node, and we need a previous node. So at first, the head is obviously going to be pointing to this. That's what they give us. And then this will be null pointer. Like next will be null pointer, and then previous will be null pointer as well. And we'll need to basically assign those in our list. I mean, really, next would be assigned to this 2, and then previous would still be null pointer. But the first step in our algorithm is going to be actually to fix this next pointer so it's pointing to the correct thing each time by checking what head next is pointing to. So we're gonna loop while the head node is not null pointer. So once our head node becomes null pointer, we know to stop looping. So our first step here is going to be to set the next node to head next. So we're going to assign next to whatever head next. So that assign it to whatever. So it's going to be pointing to whatever this pointer is pointing to. So this is going to look like this. Okay, and then the next thing we want to do is head next. We want to start reversing the list. So we want to point this to previous. Right now, previous is null pointer, and that is correct because this is the beginning of the input list. So it's going to be the end of the output list. And the end of the output list, the end of a linked list is the last node is pointing to null pointer, right? So we're just going to say this points over here to null pointer. And I guess so this looks less weird, I'll point it this way. But you get the picture. It should be pointing to previous. So anyways, yeah, so head next is going to be pointing to previous. Okay, now the third thing we're going to want to do is we moved the next node, we reversed the pointer, and now we need to move our previous and our head pointers, right? So before we can move our head pointer down to next, we don't want to lose track of this node over here, this part of the list. So first we're going to move our previous. We're going to assign that to whatever head is pointing to, just to preserve that part of the list, the new part of the list. So yeah, let me show that. So that looks like this. And then we're going to assign head to next and start moving down the list. We can now safely do that. Okay, so that's one complete iteration on this algorithm. Okay, so let's finish it out. So next, first up is assigning next to whatever head next is, right? Getting this one updated. Okay, then we're going to reverse, right? So we're going to assign head to previous, right? So now whatever, head next to previous. So whatever head next was pointing to, it will now it'll now be pointing to the previous, whatever the previous node is pointing to, right? So that's the reversal. Okay, and then we want to move previous and head along. So let's do that. And the first thing we want to do actually is the previous, right? That's very important that one happens first, and then the head happens, that one happens second. Okay, and then let's see, that's another iteration, right? So one more. So that's not what I wanted to do. I wanted to get rid of this one so I can point it to head next, right? Which is now null pointer, but that's okay because this is going to be the last iteration. So we're not using this. We're not going to be moving this. We're not going to ever be trying to move this pointer again because here in a second, this is going to be equal to null, and we loop while head is not null, right? So, okay, so we're going to do the reversal. Whatever head next is pointing to is now going to be pointing to whatever this previous node is pointing to. So let's reverse that. Boom. Okay, and then previous is going to be equal to head. What the heck? Okay, so previous is going to be pointing to head, and then head is going to be pointing to next. If I can even like grab it from behind there. This big arrow that I just drew over it. Okay. Okay, so that's the final iteration because now head is pointing to null pointer. And as you can see, the previous pointer is going to be pointing to the new head of our reverse list. So we're just going to return P at the end of this, and that's it. So yeah, let's code that. So we're going to have we're going to need those 3 list node pointers. Now they already give us one in the input to this method. So let's just reuse that one as our middle node. But otherwise we're going to need a previous node, and we can set that to null pointer. And then we also need a next node or a pointer to keep track of the next node in the list. So yeah, we're also going to send that one to null pointer. And then we're just going to loop while the head node is not null pointer. So we can just say while head. And we already know we're going to return the previous node because that's going to be the new head when we're done reversing with this algorithm. So the first step is going to be to assign the next node to its updated location. So whatever that's going to be, whatever head next is pointing to. So we're just updating that next pointer. And then the next thing we're going to do is we're going to reverse, right? So we're going to assign head next to the previous pointer. And then after that, we're going to assign the next pointer to the head pointer. Sorry, not the next pointer, but the previous pointer to the head, right? Because we can't move the head yet. First, we have to save that new portion of the list by assigning previous to it. Okay, then we can move head to next. Okay, and that's a single iteration, and that's pretty much all there is to the algorithm. So yeah, just a couple things to remember are, you need those 3 pointers, and you've got to do the save the state of the 2 lists in the right lines, so you're not losing portions of the list, right, in memory. And yeah, that's pretty much it for the code. So hopefully this helps, and I'll see you guys in the next piece.